Hello, my name is Mary Pedley, and I am the Assistant Curator of Maps at the Clements Library, part of the University of Michigan. Today I'd like to share with you a map in our collection that is rare and relatively unstudied, the Cassini Planisphere of 1696. Its story will illuminate a theme dominating the news today, which serves as the title of my talk, Testing and Tracking: How Maps Visualize Science. In a time when the words testing and tracking are becoming a daily mantra, it is worth pausing to think about what these words mean. Testing, the controlled and repeated process of assessment, and tracking, the recording of who, what, where, and when, are fundamental components of the scientific method. The graphic visualization of testing and tracking reinforces their impact. The clearest and most current example of such visualization is the COVID-19 dashboard produced by a team of engineers at Johns Hopkins University. The stark black background of the world map, pocked by the graduated red circles of known cases of COVID-19, can startle us by the density, distribution, and constant animation of the red circles. The remainder of the dashboard includes data continually updated that is used to generate the circles on the map. Distribution of data in space is the most common definition of thematic mapping. Thematic maps provide the where that underpins tracking who and what of testing. In the 21st century, knowing the where or location relies on coordinates generated by a galaxy of communication satellites orbiting the Earth that respond to signals from places like our cell phones to track where we are. These coordinates are used to locate a place on the grid of longitude and latitude that cover the Earth. The idea of this location grid had been developed by Greek astronomers in the 3rd century before the Common Era and codified by the Greek geographer Ptolemy in the 1st century, nearly 2,000 years ago. Yet the methods of securely ascertaining the more elusive of these two vital coordinates, longitude, was not fully developed until the 18th century in Europe. The Clements Library holds a rare copy of an unusual printed map that marks an early moment in the testing and tracking of observations of latitude and longitude. This plain and rather unprepossessing map was printed in 1696. Measuring about 22 inches in diameter, it is entitled Planisphère terrestre, or terrestrial planisphere. The word planisphere normally refers to a star chart, in which the vault of the skies is flattened to a circle for ease in identifying and locating stars and constellations, a visualization familiar to stargazers today. A terrestrial planisphere performs the same feat to represent the Earth. It squashes the three-dimensional spheroid to a flat surface, here centered on the North Pole, extending as far as the Southern Hemisphere, incorporating as well as distorting the continents of the globe. The title of the planisphere continues around the edge of the map, where are marked the longitudes of diverse places on Earth found by the observations of the satellites of Jupiter, prepared and presented to His Majesty by Monsieur de Cassini, Director of the Royal Observatory. An additional note explains that the places whose longitude had been observed are marked by stars or asterisks. On the map, they are small and difficult to detect, but they are the map's most important feature. This detail of Europe shows asterisks for observations made in London, Paris, Dunkirk, Bayonne, Marseille, and as far afield as Constantinople, Alexandria, and Cairo. The observers in these locations were following strict guidelines created by Jean-Dominique Cassini. Born in Italy as Giovanni Domenico Cassini, he was headhunted by King Louis XIV and his Minister of State Colbert to leave his position as chair of astronomy at the University of Bologna to come to France in 1669 to help design the new Paris Observatory, seen here in the background with its up-to-date large telescope. Cassini created a research program that focused on the two great questions of the day: determining longitude more accurately and defining the true shape of the Earth, whether it be a perfect sphere or a spheroid. To accomplish this, Cassini needed not only the building and equipment for testing, observation, but also a space for tracking the results. The planisphere we have been looking at is the printed version of Cassini's research dashboard. Our 2-foot printed planisphere was originally an 8-foot diameter manuscript map drawn on the floor of the round room of the west tower of the observatory, highlighted here. As reports of measurements from observers came in from all over the world, Cassini and his assistants marked the data from their reports onto the planisphere. Cassini's guidelines required observers to view the regular eclipses of the 4 satellites of Jupiter and to compare their local times to the times of observation in Paris. The time difference determined terrestrial longitudes with a precision heretofore unknown. The 43 asterisks on the printed plan show just how far afield observers traveled, not only in Europe and the Near East, as we have seen, but also to North America, to Canada, Quebec, to the Caribbean, to Martinique, Guadeloupe, and Cayenne Island, to the southern tip of Africa and the Cape of Good Hope, and to the Far East, to Goa in India, Siam, and several places in China, including Beijing. The results showed that the new longitude readings were smaller than those marked on contemporary maps. One result of these observations was to correct and reduce considerably the outlines of nations like France, as seen here. The fainter, more westerly coastline marked the western limit of France as recorded before Cassini observations. The thicker, darker line, the shape after the observations. The new shape caused the king to ruefully observe that the expensive work of scientists had caused him to lose a good bit of his kingdom. Cassini's planisphere was printed in 1696 because the original large map on the floor of the observatory began to be worn away through repeated erasing, re-inking, and constant use. As a printed map, it is no longer a dynamic dashboard for research, but a static reminder for the public of how science works and the important impact of testing and tracking. The planisphere does not represent the solution to the problem of location. It represents the beginning of a solution which has persisted through the next 3 centuries of testing and tracking and continues to this day. This is the stuff of science, scientia, whose Latin root means to know. Testing and tracking leads us to knowledge, which always moves us forward. Thank you for listening today.